I've been talking about this pass by copy of value, and I have some examples to kind of show you what that's about and kind of what it can and can't do. There's like a little gotcha that I'm going to try to point out. Talk about command line arguments. We've already kind of touched on that. I'm going to look at that again. And then talk about variable length parameter lists. This is a relatively recent feature that Java added, and again, in response to, people, for some reason, some coders act like every time there's a keystroke, they have to pay a fine or something. So it's like, I gotta save a few keystrokes. So, nevertheless, I have found this variable length parameter list to be useful in some context. So it's important to understand what it is and how it's used. And then we'll talk about two-dimensional arrays. Again, this is another something that you've probably encountered in your previous languages, and just show you how Java does it. Where's your little mouse here? Okay, yeah, so before I get to that, okay, yeah, here's, again, this is all in GitLab, so if you've pulled your code, you should get this. Okay, here's the deal. There are situations where you might want to take two values and swap them. Or that is, you have two variables, and in this case, x and y, and I want x to be the value of y and y to be the value of x. The standard way of doing that is to first create a temporary variable for one of them, then set that equal to the other one, and then finally set the other one equal to the temporary variable. So this little snippet of code is something have you seen this before? I mean, this is...
It makes sense, but I necessarily haven't done
okay, yeah.
swap before.
Well, this is how this is the standard way of doing it, you know. So it's like, you got to be careful. You can't just, like, if you leave this temporary thing out and you say A is equal to B and B is equal to A, then they're both equal to the same value. So you need a third one where you temporarily store it and then swap the two. So, and that's something that one occasionally has reason to do. I mean, I have seen this particular thing in every language I've ever programmed in. I mean, the need has come up. So just, okay, so it stands to reason then that you would write a method called swap where you give me two integers and it does the swap. And so after it's done, whatever two values you've passed in will have switched places. You know, whichever two variables you put in will have switched their values. Now, that makes sense, and it will fail. And it will fail because of the way that Java passes these values. Remember that when you call this, whenever you call a Java method, and this is the thing you should remember, instead of a whole bunch of rules, copy by value. It passes a copy of the argument. Okay, so that's the those are the pass by copy of value examples. And so it's important to understand that when, you know, when you're passing primitive arguments, they're not going to be the same. They're going to be the same after in the calling place. When I pass object references, though, it won't change. I can't change the object reference in the calling method, but I can change things in the object itself because that copy of the object reference refers to the actual object. In the case of arrays, they refer to the array. Okay, we've seen a little example of the command line arguments. That mysterious string bracket args that we've seen since day one of the hello world. What those are the command line arguments. Where that comes from is back in the dinosaur days. You ran the program from the command line. You say Java and then give the name of the main class. And then following that, there would be a bunch of things that you could optionally put in. We've seen that's how you can pass in. That's a way you can pass information into the program. So here, here's a little. Was this minor there? I think this is. Yeah. So just here's a little program to echo the command line arguments. So, but all the rules sort of apply. So args is a parameter to the main method. It's an array of strings, and it will exist only for the duration of the main method, which is the whole program. So, but it's only going to be around in the main method. Now I can take these values and pass them to other things, but I have to. But here I'm just saying, okay, when I run the thing, I'm going to say this is how many command line arguments there are, and I'm just going to print them out. Okay, so now when I run this, I get 0 command line arguments. Okay, why? Because I'm just running it from here. How do we get command line arguments in when we're running in NetBeans? If we were running on the command line, we would just type them in. Well, that's where this little drop-down thing up here goes. We've sort of touched on that earlier, but we can create, notice with the new button, I can create new configurations. And so here, and actually we've done this a little bit before, but we're going to do it again. Just understand, when you pull the code, these will show up in your project, but the arguments won't. Just so you know, that's just what Git does with them. Okay, so where do I put the arguments? In the little text field that says arguments. Now there are other things there, but so if I run it from here, it will give me my 5, in this case 5 arguments, however many there were. Okay, so that's how the command line works. Okay, so variable length parameter lists, or sometimes it's called varargs, and that's just a matter of kind of convenience. If we didn't have this, so let's say we wanted to, we had a method in this case called average that took a bunch of integers and returned the average of them. Well, here what we want to do is we want to be able to just sort of pass in the numbers for whatever reason. Sometimes that's convenient, sometimes this is actually more of a pain than it's worth, but for whatever reason we want to do this. So I want the same method to take either 3 arguments or however many arguments I want to give it. Now, up to a certain version of Java, that was simply not possible. You'd have to write it separately. But thanks to the variable arguments list, well, okay, what are the possibilities? Well, one is I could define average for 1 argument, average for 2 arguments, average for 3 arguments, average for 4. I mean, that gets kind of ridiculous. So like if I want to take the average of 1,000,000 values, then that would, of course now this would be a bit more challenging for 1,000,000, but instead what we can do is we create a variable length argument list, parameter list, and it looks like this. It has 3 dots. Looks kind of weird. So here we would define the variable argument as, in this case, int followed by the 3 dots. And they put a space there That space is optional. I usually put the 3 dots right next to it. Doesn't really matter. But the type is of the, so this is the type. And it's a variable argument, and then this is just the dummy argument variable. Now what it does on the inside is it turns it into an array. So inside the method, you treat it like an array. So here's their implementation of this average. So actually, this is actually not really necessary, but we have the sum. We iterate over the list, just like it was an array. We add each of them to the sum. We divide by the length of the list, so because inside it literally is an array, and so we can apply anything that we can do to an array, in particular the length. Take the number. Again, we have the integer divide problem, so we cast the numerator to a double. That turns the whole thing into a double. An example which also has an interesting little tidbit. Okay, say they want to define a class called family, and it's going to have an array of strings called its members, but we don't, for whatever reason, they don't want to create an array of strings and pass it in, which would kind of make sense. Instead, they just want to pass in a variable argument list of the strings of the family members. Okay, but we can then take the argument of the constructor and then assign the instance variable of the members. And now, again, this would be a copy of the array. However, because when you call it, when we call it, you would call it with this list of strings. So what Java does is Java creates the array under the hood, and so there's no array, there's no string array here to be copied. The one that gets copied is the one internal to Java that creates it. So that's what makes this kind of safe, but there's a little gotcha here that really involves some others. So all this is just the family members, and then the toString that prints them out. So here they create two families and just print them out. And the idea is that there are different numbers in each one. Okay, so that's how that works. There is a little gotcha, though, that I want to point out. This works because of the way that this is designed, and I added the final, because this, even if this is final, though, there's like a little gotcha here. Now, they don't have a getter method for this, and it's probably a good thing that they don't, but when you have getter methods and even setter methods for arrays, then it's a little bit tricky. And let me show you why. Supposing we wanted to have a getter method for the family members. And we're using the refactor encapsulate fields thing to just generate one. The problem is, this is a problem. This actually violates encapsulation. And I'll show you why. Because supposing we had that getter method, we can now, let's say, get it. So let's, okay, so we have a getter. This will return the guys there. But now we have This is returning a reference to the actual instance variable. And so now I can do something with it. Okay, see what I did? All I did was this is all something which is a reasonable thing to do on the face of it. I say, well, what if I wanted to get the individual members? Write a getter method. Okay, so there it is. And now I have this string array, and I say, I don't like the guy at 0. I'm just going to replace that. Now what's going to happen here? All of a sudden, poor old Stephen has been replaced by Groucho. So that, so we've done something that's kind of, on the face of it, is reasonable, and yet it is, as I said, it's violated encapsulation. Why? Because this is returned the actual reference to the instance variable that allows, and because anybody who has a reference to an object can manipulate that object if they can, and for an array, I can manipulate the individual indices, as I've done here. Change the 0th one. All right, so supposing I still want to do this, but I don't want to violate encapsulation. Well, it turns out that arrays always have a great method for doing that. It's called clone. So now, whenever you have a getter method for an array, and this is also true for setter methods, always do a clone. And for 99.9% of the time, that's going to, I'm trying to think of a case where I didn't do that, where that was not the right thing to do, and I can't think of one, to be honest. So I'll say 100% of the time, always when you have an array instance variable and you want a getter or a setter, always clone it. Now, okay, I'm trying to do the same thing, except now Stephen does not get replaced by Groucho. Okay, why? Because clone returns a copy of the array, of the whole array. So in other words, this copies the whole array into an entirely new array. And so you can do anything you want with this. In fact, if we debug it, we see that here, and we see an array, we can open it up in the variables list. Be a little small, but if you look here, this array has Groucho in the 0th one. Nevertheless, in the object, in the Camden family object, it's still the same because I've created a whole copy of the array. And so if I have a getter for an array, and you return a copy, then you can do anything you want with the copy, but it won't affect what's inside. And that's an important thing to remember. Okay, so here's just another example of using an object. We can use an object for the variable arguments. That's okay. Distance returns the sum. Again, very straightforward. Okay, here's the thing to remember about variable argument list. If you have more than one argument, you're only allowed to have one variable argument, and it has to be the last one in the list. That's the rule. So you can have other things, but the variable one must be the last one. So here I can have a count, a name, and then however 0 or more doubles. So a var_args makes it optional. So if I have a var_args, I can actually pass nothing there, and that will be legitimate. What it will do under the hood is it will create an array, in this case an array of doubles of length 0. Okay, yeah, as I said, it must come last, and you can't have 2 of them. You can only have 1. You can do them in constructors and methods. Okay, that was their little example that we went through. Okay, so 2-dimensional arrays. So you've worked with 2-dimensional arrays before, is that, or yes, yeah, well, yes. If you work with matrices, then chances are you've worked with 2-dimensional arrays. To be honest, this is something that I keep always getting a little bit confused about, so I have to keep reminding myself about what's going on. This kind of goes back to the way that C does things. In previous languages, the 2-dimensional arrays were kind of more built in. What C decided to do, and it was kind of a cool thing, but you need to kind of wrap your brain around it. A 2-dimensional array is an array of arrays. And so you can think of the rows as being the array, and each row is itself an array. So it's oriented toward that. Now that's in contrast to if you've worked with languages like R and others, they tend to be more column oriented, but Java, along with C and all its descendants, are row oriented. And one of the consequences of that is that you can define them as rectangular. So in this case, table would have 12 rows and 50 columns. And you define them with a double bracket. This is one way to instantiate them. There are other ways, as we'll see. When we reference it, if I want to reference a specific value, this will reference the item in row 3, in row index 3, column index 6. So this will be the 4th row and the 7th column. But I can refer to just the regular array. So this table kind of lays it out fairly nicely. So the table reference points to a 2-dimensional array that has the whole thing. If I refer to one index, that will refer to the array of integers in that one row. So this will refer to an array, a single array of integers in the 6th row. Whereas the individual ones, the type is just the type of the array, again, in the 6th row and the 13th column. See, the book has an example for this. Let's see. Where is it? Oh, here we go. Yeah, just sort of. Okay, this is their example. So here we create a double array of integers, a 2-dimensional array of integers with 5 rows and 10 columns, rectangular. Now, remember that the rules of arrays still apply. At this point, when only this command has been executed, the value of all of the entries in the table array are the default value of its type. And the default value of an int is a 0 integer. So at this point, everything is 0. So if I want to initialize it, if I want to put values in, I need to start looping. And if I have a two-dimensional array and I want to initialize everything, chances are I will need a nested loop. So here I loop over the rows, and then over for each row I loop over the columns. Now this is a good example of how to have the upper bounds. When you're looping over arrays, it is important to use the length of the arrays as your upper bound if you're looping over everything. So table.length, remember that this is an array of arrays. So table itself, length, is going to tell you how many rows there are. Each row is itself a single dimensional array. And the length of that will tell you how many are in that row. So this is an exemplar of how to do this. In other words, when you're looping over an array, always use the length of that. And in this case, we're looping over the row, and we want to use the length of that row. Now in this case, they're all going to be the same. But I'm going to show you a case where they don't have to be the same. See, that's a little gotcha there, where because it's an array of arrays, there's no guarantee that each of the rows has the same length. There's no guarantee that it's rectangular. Nevertheless, when we run this, just sort of we're printing out every row. So this is basically what this matrix looks like. However, let's see now, where's mine? Yeah, sometimes it's called a ragged array. Okay, so here's how you define them. So here's values, which is a double array of integers. But then notice that I'm only instantiating the rows. So this is how you do it. I need to give a number here because I need to tell it how many rows I have. But by leaving the bracket empty here, I'm saying I'm gonna tell you how many are going to be in each row later. So at this point, now can you guess what is, after this first line is executed, what is in values?
0.
That makes perfect sense. But that's not what it is.
It's one column.
Yeah, well, yeah, it's essentially like one column, and what's in that column?
Null value?
Null, exactly.
I don't know why.
Yeah. Okay. All right. So yeah, we can unpack that. Again, it's an array of arrays. So I've said I have 10 rows, but I'm not going to do anything about what they are. I'm just telling you I have 10 of them. And because I haven't instantiated them yet, and because an array is an object, it has its default value. So at this point, I have 10 nulls. And let's just double check that. And so here's values, and we see that there are 10 index 0 through 9. And their values are all null. Now, I mean, that wasn't obvious, but I mean, you have to really kind of think through the whole thing. So
since it's not complete, it's seen as a declared variable.
Yeah, this is just as if I declared an array of objects, but before initializing the objects, their default value, which is null. So All right, so here's how I'm going to initialize them, though. So because I've declared them this way, I need to go through and do each row. So here, my outer loop is going to give me an upper bound of the length. That's going to be however much it is. So now, I need to explicitly instantiate each row. And what I'm going to do is I'm going to instantiate it as one plus the row number. So the first column is going to have an array of length 1. The first row is going to have an array of length 1, the second one an array of length 2, etc. And then I'm just going to assign, now for having done that, I can now go, here now it's critical that I go through the length of that, because the length of each row is going to be different. And I'm just going to assign, I'll just assign the sum of the two things. And now when I print it out, again, I need to do the same type of printing, and what I get is basically what is called a ragged array. I mean, in this case, it's like the first one has 1, second one has 2, third one has 3, etc. Okay, so what that means is that multi-dimensional arrays in Java are very flexible. And this is true in other languages as well, just because Java took this from C, and other languages have taken things both from Java and from C, and so this is pretty much the way things are done in modern languages. And my only complaint about it is the silly zero-based indexing stuff. Okay, so where are we here? Yeah. Okay. So and we can extend the whole thing pretty much indefinitely using the same type of deal. In object-oriented design, however, I only on very rare occasions do I use two-dimensional arrays. I have never found use for three-dimensional arrays or above. In procedural-oriented languages, you will sometimes need to do that. In most cases, if we're in an object-oriented environment, we can use objects instead to perform basically the same tasks. Okay, so now we're going to circle back to chapter 7 and delve a little bit more into object design. And just a reminder for assignment 5 that the Javadoc comments are now required. So up to now, I haven't been dinging you if you haven't had comments. I know some of you have comments, some of you have not had comments, but now everybody has to have comments, or else you'll get, I mean, not, if you have a correct program but no comments, it's not going to be a total, I'm not going to clobber you, but writing comments on methods and on the class are important. You know, I don't want War and Peace, just explain what the thing does, so that if somebody were reading that, they would at least know what this method is supposed to do. And that's an important, that's part of programming. That's not an optional thing. That's something that's really very much part of it. Okay, so that does